Gallant Conversations. Today, it's an awesome episode. This is the first time we've ever had two people kind of doing an episode with one another. So, again, I want to leave it to y'all, just kind of give a quick little intro. But we have Steve here with HEPHAE and then Torsten with Underground Ventures. Steve, give me a little rundown, elevator pitch on you and HEPHAE.
Man, thanks for having us. This is great.
Thank you.
Great company. Yeah, Steve Crace. Actually, my degree's in geology. I like to say I haven't hit a rock with a hammer in a long time, though. I'd like to change that, though, at some point. But yeah, 44 years of experience in oil and gas up until the last 4 years. So 40 years oil and gas, and the last 4 years have been completely focused on the geothermal space. Background started out doing petrophysics, understanding where oil and gas is in the reservoir, and where it is in the reservoir. And then 1984, I joined a company called Teleco, which were the pioneers in what's measurement while drilling, MWD, which is the technology by which you get data while you're drilling and transmit it back to the surface without wires. So you can make real-time decisions about where you want to go, where you are, and what type of rock you're in. And then 4 years ago, my co-founder, John Clegg, and I, we recognized that next generation geothermal, unconventional geothermal, needs the exact same tools that we've been working on for the last 40 years. It just needs to work at temperature. So that's our mission, and that's what we're working on.
That's awesome. And I like the shirt, man. That's
Thank
pretty
you.
cool.
Thank you.
For sure. And then Torsten, I mean, give us a rundown on what do you got going on?
I was gonna say, I'm sorry, I'm not.
But
wearing,
I have a shirt for you, by
I'm
the
sure
way.
I'm not wearing the company colors here, but they do exist. We just had hoodies made, Underground Ventures hoodies. They're in very high demand. But yeah, thanks for having me on. Torsten Koland, managing partner, co-founder at a venture firm called Underground Ventures, as you said. So far, the world's only specialized geothermal venture firm, and that's kind of weird. You know, I hope to get some more of a fun started, but it's a very specialized field. So my own background is engineering, but it's not oil and gas or geology or anything actually useful to this. It's biotechnology engineering, but at least some sort of engineering I think is a useful start. I was 10 years in software out in San Francisco, so again, totally different field. And then I became both personally an investor, so-called angel investor as an individual, and a professional investor. I angel invest in the field of women's health, and I'm a professional investor with Underground, specifically in geothermal energy. So those are two very different fields also. So a little bit all over the place.
Yeah.
I can tell you more about Underground Ventures, but that's me.
Well, and it's kind of a fun little relationship that y'all two have, right? So, I mean, Steve HEPHAE is a portfolio company of Underground Ventures.
That's right.
So
that's right.
Full
disclosure.
Yeah, full disclosure right there.
I have seen this man before. That's right.
Yeah, and so talk to me. I kind of want to just go back and forth with both of y'all, and talk to me a little bit about the origin story of Underground Ventures, if you don't mind.
Absolutely. Yeah. So a few years ago, a fellow software founder from an SF-based software company called Unity decided that he wanted to put in some of his personal wealth into the field of geothermal energy. And this is the software company he founded is called Unity Technologies. It's traded on the New York Stock Exchange, so it's a big company today. But all three founders have, after going public on the stock exchange, gone into different kinds of energy or climate investment. So Joachim Ante, the former CTO co-founder, which is my co-founder in Underground Ventures, decided that geothermal energy really needed a specialized venture firm, and he decided that he was willing to take that risk himself. So he has put in $40 million of his own wealth into this project to be invested into 10 different startups over the course of a couple of years in this space. So it's a very big, very big commitment, and something that is very rare. Most venture funds are sort of funded by different types of retirement funds or family offices or other kinds of investment firms. But this here is all his own choice to go into this field. And that allows us to be really, really bold and really specialized, which makes my job a lot easier.
Yeah, and y'all are based where? EU?
We're based out of Copenhagen, Denmark,
Yeah.
but there's not a lot of geothermal in Denmark.
Not yet.
Not yet.
It's coming.
But if you want to be this specialized, there is no way other than being fully global in your approach to where you're allowed to invest. So first, 4 investments, 2 are in North America and 2 are in Europe. So we're fully global, but headquartered in Northern Europe.
Yeah, and so the relationship with HEPHAE, I mean, just walk me through kind of like kind of your reasoning and logic in respect to kind of what you find interesting in HEPHAE and what Steve's doing, and then maybe Steve, if you don't mind, just kind of diving a little bit deeper in terms of the technology and
Sure.
the UMB.
Yeah, I almost feel like you should explain what you guys are doing in a little more detail, and then I can build upon that. That's probably better.
Yeah, okay, so I'm happy. Yeah, that makes sense. So with next generation geothermal, as opposed to conventional geothermal or hydrothermal, you're targeting steam or hot water. In the case of next generation geothermal, you're targeting just dry rock, hot dry rock. And one of the things that we learned early on in this is that in the case of next generation geothermal, when you're targeting hot dry rock, hotter is better. The hotter the rock you can put your wells into, the lower the cost of the electricity or the LCOE improves the hotter you go. And we recognized pretty quickly, well, the reason we're in it is we recognized, I think as I mentioned earlier, is the tools that you need to drill these next generation geothermal wells are the exact same tools that we've been developing for the last 40 years to drill horizontal wells in unconventional oil and gas. If you're not familiar with unconventional oil and gas, it's all about wellbore placement. You've got to put wells 3 miles down, 3 miles out, sometimes within a 6-inch or a 12-inch or a 3-foot sweet spot. And you've got to place those wells, factory drilling, hundreds, thousands of wells, exactly the same. And unconventional geothermal, next generation geothermal, is exactly the same thing. It just needs to operate at a temperature never seen before in the drilling world. So that's what we did, and I think that's what got Torsten's attention, is that we've got a solution here that not only applies to drilling these wells, but also in the completion and the production side of it. Because in this environment, first of all, hotter is better, and you need electronics on the drilling side and the completion side, the production side, and probably other places where you need high temperature electronics.
Yeah, and I remember you did a presentation at NOV, and you were providing some graphics in your presentation with the circuit design.
Yes.
And I mean, do you care to just kind of walk us through that? If you can just, I mean, yeah, you can picture it in your head, probably.
Yeah.
Your slate.
Well, I mean, I think the most important thing is, even though I'm a geologist, I've been doing product development for a long time. And one of the things that I learned from a gentleman by the name of Don Wiesenberg, who was a great mentor to me when I was at Baker Hughes, PhD, Stanford, mechanical engineer, Sandia Labs, also All-American wrestler. He was about 5'6", had a freaking cauliflower ear. He was a tough guy, man. And anyway, but everything I know about product development, I learned from him. And what he told me was that, look, Steve, first of all, you got to separate research from development. Figure out what's research, and do that first. And a lot of companies, they mess up and they combine research with development, right?
Yeah,
Before you know it, you've gone out of bounds. So, kind of going off on a tangent here, but at the end of the day, we started with a blank sheet of paper. That's the other thing he taught me, is that if you want to step change your performance, you've got to start with a blank sheet of paper. And right now, typical oil and gas electronics are rated to 175 Celsius. We feel like we have to go to 300 Celsius. You're not going to get to 300 from 175 by tweaking things. You've got to start with a blank sheet of paper, and that's what we did. And so our electronics packaging, as opposed to long skinny boards, we've gone to these circular boards in a very unique package that dissipates heat quickly off of the electronics, which is the killer. So That's the,
Where did you get that? I mean, like, is that just like a common practice in electrical circuit building and board?
no. It's
like,
actually got nothing to do. With, it's got nothing to do with electrical. It's got nothing to do with electronics or electrical stuff. It's all about mechanical engineering.
Yeah.
And the mechanical engineering piece to this is the game changer for us. And most of our IP is around the packaging and the mechanical engineering. And the other thing that we learned, or we didn't learn, but we've picked up on, is if you want to do something impossible, find people that don't know it's impossible, which is what we did, and that's why we have our mechanical engineering department is in Spain. They've never seen, when we showed up over there, they had no idea, nothing about drilling, nothing about downhole, nothing about geothermal, nothing about oil and gas, but they knew a lot about thermodynamics and how to move heat, how to move heat. So we gave them the problem. They came up with a unique solution, and the guys that have the experience in all this helped them a bit. We just point them in the right direction, right?
Yeah.
And that's turned out to be really a game changer for us. Is moving our mechanical engineering team outside of U.S.
Yeah, you just let them eat, and
yeah, it's been great.
Yeah,
it's been a great.
No, I mean, it's incredible. And then Torsten, I'm just, again, like with HEPHAE, I mean, like, what do you look at in terms of kind of your portfolio companies, and what kind of differentiates HEPHAE from the other folks that you've kind of looked at in the geothermal space?
Yeah, so I think Steve said most of the good stuff here, but I'll just point out that for us to get to a long-term vision of I think the IEA, the International Energy Agency, projects about 15% of global power production being geothermal by 2050. So in 25 years from now, which is roughly the same, by the way, as wind and solar put together today. So it doesn't sound like a lot, but it is an enormous amount. And so if we are to get to that, the only way there is to go through continued radical technology innovation. It's not going to get us there by, as Steve said, just looking for water, steam reservoirs or traditional geothermal. We're going to need to go to hot, dry rock, and we're going to need to go to technologies that allow us to do this almost anywhere on the planet, and that at an attractive cost profile. Because that's the other thing. A lot of renewable energy has happened due to government subsidies and other types of help. I think we're looking at the next 25 years globally. These things are only going to happen if they are economically sustainable in and of themselves. And so that brings me back to so we're looking for those, first of all, for that very long-term view, very high scale, and that means we're looking for people that go back to the drawing board and say, okay, we're not just doing incremental innovation on some oil and gas technology. We're trying to figure out how this should have been built from the get-go. And I think that, for me, with HEPHAE was the number one thing that I was interested in. I saw some people here that were very, very committed to doing this right, and that's why it's been very, very thoroughly tested, and is being very thoroughly tested, which is amazing. But that for us, that's our job. I feel as venture capitalists, we have to look long term and take those leaps of faith that perhaps a customer today might not be as ready to take. I think that sums up the key points here.
Yeah, I think to add to that, Torsten, it's kind of funny when John Clegg and I, my co-founder, we started looking at this. We kind of made a similar assumption. We just said, trying to figure out how big could this market be, and we just took an estimate. We said, what if 18% of this increase, just the increase in electricity demand, comes from geothermal, and it's 1 million wells by 2050. We have to drill 1 million wells, right? Which seems like a lot, and it is a lot, but it's kind of on par with what we do with oil and gas. So it is possible, and but the first couple of years we didn't tell anybody that, because everybody would think we were crazy, and we let it slip a couple of times and everybody thought we're crazy. But now the numbers coming out from IEA and Rystad, they keep getting bigger and bigger every year, and now we're just about to that million well. We're just about to that million well place again. So it seems like we're pretty close.
Yeah, that brings up a hot take. The Texas Railroad, we're in Texas, and there's a Texas Railroad Commission that kind of helps oversee abandoned orphan wells and all that stuff. I think they're spending, God, last time I checked, they were spending $25 million a year capping and kind of making sure that everything was environmentally regulated and like safe and sound and all that stuff. That being said, with the million wells, I mean, what do y'all think in terms of like, is that a way to kind of gain some market share and kind of take existing infrastructure? Because there's also been kind of some thoughts on retrofitting existing coal-fired power plants. Texas ranks 6th there in terms of power generation, its energy profile mix. I mean, how do we get a million freaking geothermal wells and more up online ASAP? And is the abandoned orphan well something that can maybe consider, or?
You want to answer that? Or you want me to answer that?
I'm happy to go first.
Go ahead.
So I think first of all, let's see if we get to a million. I think we're also seeing the performance per well go up, and there's a number of things that look like we're going to see higher production rates per well. So it might only be a couple of 100,000, but it's still a lot. But just to put that in perspective, the oil and gas industry globally today drill about 85,000 a year. So you might say, let's say we need 200,000 or 300,000 in 25 years time. That's not in any way insane, given what we're currently doing.
Yeah.
So that's just like that perspective is important. I think the repurposing, there's absolutely no reason not to do that. Let's do it. I think it's a case of all of the above. There are just different economics. Like there are different energy production sort of physics and economics per well, depending on how deep it is, how the flow rates are. And also where it's located. If you can produce, let's say, electricity and you have nowhere nearby where you can use that electricity, the grid may not be set up to take that off. So I think it's all of the above, and we are seeing a very, very strong expected increase in demand globally. So for that reason, we don't have the luxury of saying, oh, we only want hot dry rocks or we only want repurposing. It's going to be all of the above, if you ask me.
I think that that's the other thing about geothermal. You have to be really careful about what you're talking about. Each direct use and super hot, super critical. I mean, it's all over the place. A lot of opportunities. And I think at the end of the day, if you've got hot water coming out of the ground, you don't want it to go to waste. If you can figure out a way to use it, then we need to figure out a way to use it. But to Torsten's point, in the Permian Basin, where you've got a lot of hot water coming out of the ground, there's no place to put the electricity, right? The grid is extremely congested, right? And so we have some infrastructure challenges ahead of us. Now, the coal to geothermal, love that because you've got the power plant is right there, the grid is right there. I love that, and so I think that makes a lot of sense.
Yeah, I mean, in my mind, it's like, okay, we have all these freaking windmills in West Texas. You're capturing wind. Why don't we just capture this heat, this steam at the same rate, right? Like, come on, let's
go.
Yeah. So, okay, I kind of want to pull it back and then reposition, whereby, okay, you're in the EU, you go all over the world. I mean, you too, in your own right, you're all over. You got Bilbao, Spain, you got freaking Texas. You're kind of juggling between the two. I'm sure you're going all over the place too, Steve. But what do you think with the current administration with the U.S. and then like the EU and kind of the clean energy? Like, what do you have to say there? What are your insights?
Should I go first?
Go ahead. Go ahead, man. Yeah.
So I think a couple of things, right? The current administration is changing a lot of things, and they have good reasons for doing so. And I think the good thing about geothermal energy is that it's a very bipartisan. Everyone likes the concept of clean, safe baseload energy that doesn't require imports from other countries. That are secure in almost any situation. I mean, this is it's just an energy form that checks all the boxes for everybody, and that is extremely rare. So that's, I think, just a good starting point. Yes, of course, there's some different priorities in, let's say, the EU versus the US right now, but it doesn't really matter. I think the US, particularly right now, is a very, very good time to go and build geothermal energy, whether you're doing greenfield development, new wells, or you're repurposing wells. There's a lot of interest in furthering this, in fixing some of the bureaucracy around permitting and grid connections and all this stuff. We've yet to see it happen, but I'm hearing a lot of the right things, at least. So I'm not too worried. I mean, there's things are happening anyway. despite what certain politicians are saying in the EU or the US. So,
is there anything that you see happening in the EU that you would like to see in the US?
Well, I think there's a little bit more of an immediate need to transition away from, for instance, natural gas imported from Russia.
Yeah.
And I know it sounds insane to say, are we still importing natural gas from Russia? But yes, we are in the EU a lot. Some countries are still buying quite a lot. So you have that sense of urgency that I think is a little bit different in replacing those energy sources. Now, at the moment, they're replacing it with a lot of wind, a lot of solar, a lot of renewable energy, but there's absolutely no reason that couldn't be done with geothermal, and it is happening. So that sense of urgency, I think, here we're in the US, I'd see it a little bit more as it's an opportunity. It's an opportunity to become more energy self-sustaining, even export more energy, have the right energy sources. It's an opportunity, but perhaps not the sense of urgency that folks in Germany or Poland have.
Yeah. And I mean, like, my understanding too, it's like West Texas, I mean, there's a lot of capital over there. And of course, in the US, you'd look at the East and the West Coast to flood capital into the market for the geothermal industry, or any industry for that matter. But like, I guess it's West Texas, and their point, it's like they're still kind of maybe trying to wrap their head around geothermal. I mean, Steve, is there anything that you would want to kind of point out to those types of investors that might see it, to Torsten's point, as like it's an opportunity, but there's still something that needs to click for them to like activate? Or
Well, I think it's actually more driven by geology.
Okay.
Right now,
yeah.
if you look at what Fervo's doing, which is that's the Drake well, in my opinion, for geothermal, right? That's the equivalent of the Drake well, the first oil well in the United States, right? What Fervo's doing is the equivalent. We're generating electricity from solid granite, which is almost as crazy as getting oil out of shale, right? What we talked about earlier today. It's kind of the same thing. It's crazy. Anybody, if you suggest this just a few years ago, people would have thought you're just out of your mind. But the Fervo approach is you've got to find a massive granite, right? Because you're creating your own reservoir. You don't want to put wells into rocks that already have fluid or fractures or porosity. You just want solid, dry rock, and that you're going to create your own reservoir, and now you've got control over the system. That's what's driving it right now. And so you've got so that's why Utah Forge, that facility, is there in Utah. That's why Fervo is right there, and there's another company that's just come up, 400C, that's taken some acreage very close by. That's what's going there. We're targeting massive granite that's hot within. You got 200 degrees Celsius rock there at 8,000 feet, right? To get that rock in the Permian Basin, you probably got to go 3 times as deep, right?
Yeah.
So so there's a combination of rock. There's a combination of depth and temperature, and then there's the ability to move that electricity to Southern California or wherever else you've got to have a market for, right? So, all those things need to come together. So the Permian, it's more about, it's not really, if you're going to do hot dry rock geothermal, you wouldn't start there, right?
Yeah.
So that's U.S. So I see it based on the back of Fervo, expanding from there, the Western United States. In Europe, a lot of enthusiasm there, but I also want to add, we've been all around the world.
Yeah.
Every country's talking about this. Every freaking country's talking about it. Indonesia, Philippines, Malaysia, even though they got steam, even Iceland, where they got steam coming out of the ground. Every place you look, right? Everybody's looking at next generation geothermal. One of the advantages that we have here is we can frack the hell out of granite in Utah. Nobody cares, relatively speaking. I mean, if we had an earthquake in Salt Lake City, it'd be a problem. But in Europe, they've had some issues with induced seismicity. So kind of fracking is kind of off the table. So at least for now. So EGS, what Fervo's doing, is coming later for Europe. But the nice thing that Europe has is they have district heating. So where you've got, hot water, some of your cities are already set up to take hot water. So you can replace burning natural gas or coal to create hot water for district heating, or for hot water for a city. You can do that with geothermal. So I think that's the advantage that Europe has. We don't have district heating set up in our cities here, right?
Yeah.
In Europe they do, and so I see geothermal, direct use geothermal for hot water being a big deal for Europe, and Edwards over there, they're going to be generating electricity, but again, got to go deep, got to get hot, you got to get into those rock temperatures, 250 degrees Celsius, which is, you don't want to have to go 20,000 feet deep to find that, right? At least today.
Yeah.
So that's kind of a long answer.
Yeah.
No, yeah. I mean, it almost makes me want to think like maybe Gallant should sponsor some sort of road show and get all these freaking these folks that see it as an opportunity. Maybe we can do this together, Torsten. I don't know, but just get all these investors, folks that are not necessarily exposed, and take them over to Utah and just be like, hey, this is what's happening. This is what geothermal looks like.
Yeah, it's an amazing story, and there's a complicated story.
Complicated story. I'd add to that because imagine if we keep talking about, you said it before, like it's a complicated, we have hydrothermal, we have next generation geothermal, we have direct use, we have super hot rock. Yeah. But imagine for a moment that geothermal energy was just invented now, that we didn't have that 100-year history of hydrothermal energy, but we just invented it now. We would be able to tell that story completely from the beginning. That this is in fact a very safe, easy, clean, scalable, engineerable type of energy source that there's no reason we shouldn't do pretty much all over the world. And I think we're a little bit stuck in that. There's still, if you to your point about West Texas, if you go to traditional infrastructure investors and you talk about geothermal, they'll think about things like, do we have even the resource here? What about dry well risk? We drill and there wasn't that resource we hoped for. This whole thing about seismicity, I want to just for a moment backtrack a little bit, because if you go to Utah and you actually saw what Forge, the DOE sponsored project, when they went out and engineered their reservoir, they created, I think it was 50,000 or so microseismic events, none of which were felt on the surface. Mm-hmm. So I know it sounds like seismicity sounds, like a problem, but what the problem is, if we don't do the homework, if we don't upfront make sure we have those analyses done and while drilling, then there is a risk. But if you do your homework, you can absolutely engineer a reservoir without any earthquake risk. I just want to point out,
I'm convinced that that's the truth.
That is sometimes I hear that sort of, oh my God, are we going to get earthquakes? Absolutely not. We would never do this if that was the sort of natural consequence, right? So.
Yeah. I don't want to interrupt. And I feel like whenever there's something, I guess, novel, new, and geothermal is not new, but when there's a new take or something like that, there's always kind of resistance at first, right? You fear what you don't understand or don't know. And same could be said about any other energy source that is known to man, right? Like solar panel and the carcinogenic emissions associated to polycrystalline and monocrystalline manufacturing of the cells.
Yep. Frontline
workers getting exposed to that, cracks in it in a community space, that then also creates a risk profile for it. Wind, again, you're extracting a lot of resource to develop out a freaking energy source with a big old wind turbine, and then you have to maintain the darn thing, right? Yeah. And you had the issue with the wildlife and the wind stuff and all that. So there's always, push comes to shove, there's always kind of pros and cons, right? And
great point.
Yeah. But the other thing, Chris Wright brought it up. I was lucky enough to attend I saw his speech at Geothermal House up in Washington D.C. a few weeks ago, and he's got a lot of experience with this. And we've been trying to do EGS for a long time, but we didn't know about how we weren't able to drill horizontal wells, or we weren't able to frack like we're doing. So in the past 40 years ago, when they tried to do this, or maybe it's not quite 40 years. They were trying to do vertical wells and just trying to make a reservoir between vertical wells, and just not enough surface area. Mm-hmm. It's not until we figured out how to drill these long horizontal wells in 2 days or 3 days and frack between them accurately that this has all become possible. So we're not here today without unconventional oil and gas. We're not even having this conversation today without unconventional oil and gas.
That kind of brings up something, because we were kind of talking about this, before, right? What do you think is a good comparison in terms of what we're seeing with geothermal and what we saw with the shale revolution? You brought some kind of.
Well, yeah, I mean, I think Fervo is the Mitchell Energy of geothermal. Like I mentioned, I mean, before Mitchell Energy, and we started producing gas and oil out of source rock. If you pick up a petroleum engineering handbook or petrophysics handbook from 1980 something, you don't target shale. you ignore shale, right? And now we target shale. It's crazy.
Yeah.
It's the world. Like I said, Pluto's not a planet anymore. All of a sudden, it's
Yeah.
not a planet. The whole world is completely changed. We're getting energy out of shale. Now we're getting freaking electricity out of granite. How did that happen?
And I mean, like in terms of like activating the capital, Torsten, I mean, you are just an embodiment of kind of helping support this geothermal industry and accelerating forward and being an enabler, if you will, to some of these companies and startups. And I mean, I'm just going to put some folks on notice, like the majors, like BP, Chevron, or whatever, Exxon. They're not touching it. They're seeing if the startup community, innovation community can really come and get some traction, get some quick wins. I mean, with you and HEFHAE, I mean, it seems like y'all are freaking ready to go. I want to touch on that a little bit later. But you're really kind of enabling and activating it. I'd love to kind of with kind of y'all's specialized focus in geothermal. Talk to me kind of like what y'all do in terms of investments, what y'all look for. Average check sizes, what are some signals that you see? Just kind of run that down from. I know, again, I'm infamously known for long-winded, open-ended questions.
Yeah, so, no, it's all good.
Just keep it flowing on that.
So I mentioned this thing about, or rather Steve mentioned the thing about a blank sheet of paper, of going about things fundamentally different from what other people do in the field. And I think you'll see that in our first 4 investments, that all 4 of them have very much fit that pattern. I mean, first investment we did was in GA Drilling, which is a company doing plasma drilling, and very high charge of electricity to essentially make microfractures in the rock while you're also drilling conventionally. Is just like radically different, but also complicated. We need a little time before that becomes commonplace. We just invested in a Swiss company called Borobotics that has a completely different philosophy on how to drill for less money. So bear in mind that a lot of this geothermal is sort of possible anywhere, but not always at a cost that can be covered by the energy production afterwards. So really, the more we can get the cost down on those initial investments of both drilling, well completion, surface equipment, whatever needs to happen, the more we can get that cost down, the more viable this industry becomes anywhere in the world, right? So the Swiss guys essentially said, everybody else is trying to get costs down by drilling faster. That's what we see everywhere, because you pay for your rigs and your teams per day, essentially. They're day rates for these things. Very expensive. They said, why don't we drill faster? Oh, why don't we save money by drilling slower? And at this point, I'm like, what are you talking about? Like, I need that explained. And then they walked through how they were going to drill slower and save a lot. I wouldn't put a percentage on it quite yet, but a significant amount of money by drilling slower. Now, they're doing shallow geothermal, so we're only talking about, let's say, about 500 feet or so. So totally different game. But they can drill without a rig. They're just going to go slower, but they are essentially cutting out a whole lot of cost by just thinking about this completely differently. And so that, I think, is also a good example of what we're looking for. Those people with that kind of mindset, you cannot fundraise in this current environment. This is still so specialized and so particular that if you also come and say every expert you find will say we're idiots, it's going to be really hard for you to fundraise. So that's what we look for, that long perspective, fundamentally different, really smart people that have sat down and thought about how to do this in a way that will work for many years.
Yeah, and you lead and follow, from my understanding.
We prefer to lead investments, and maybe just to clarify how that works, that means that we are the main interaction point with the founders, like Steve. We negotiate what is an arrangement of how much of the company are we buying for what amount of money. Typically take a board seat in the company afterwards. But venture capital is all about not owning the company. This is not, a lot of folks know about private equity, which is essentially the takeover of a company. Venture capital is very much about letting these guys, like Steve and John and the team, run and build the company like they were doing. Essentially be as much in the background as we can. So we're taking a small minority ownership stake. We're funding the company. We're trying to help out what we can, but we really have to be careful not being in the way of what these guys are doing. And that job is a very, very careful. You really have to invest in people that you believe will, without your help, run and build these companies. That's very hard. So leading just means we're there as the main point of interaction. Other investors can join. It does not mean that Steve has to do everything I say. Thank God for that.
I don't know, Steve. How do you feel about that? Doing everything that Torsten has to say.
Yeah, I mean, it's been a great experience for me. My other startups have not been VC funded. I've had the private equity experience. I've had the individual investor experience. But everything that Torsten said, I concur. And Underground Ventures has been a great partner, along with the Exoscale and Future Ventures, Grantham Foundation, Neighbors. Those are our other investors. I think I got them all. They've all been amazing and very supportive.
People.
Great team. And everything he said, I concur wholeheartly.
Yeah, no, for sure. And then, I mean, what do y'all think? Okay, so geothermal deep tech. I mean, what do y'all think is needed to kind of push it forward to the next momentum shift? I mean, I know what you're bringing to the table, your technological solution is one of those things that's helping assist and accelerate the geothermal industry. But I guess Torsten, another way for me to frame it here is with your experience with kind of engaging other VCs and stuff of that nature, I mean, do you see there being a learning gap or a resistance in investing in deep tech or specifically geothermal, and because they're maybe not have the experience and they're more so focused on software? Are you kind of providing an advocacy or a education component to other VC firms? I mean, I'd love for you to kind of...
Yeah, I mean, I have personally been through quite a learning journey, right? I got into this about 3 years ago because Joachim, my partner, came and said, he heard about super hot rock geothermal as being the sort of holy grail of future geothermal. And I went and Googled it. I never heard of it. I was like, let me try to figure out what he's talking about. That is only 3 years ago. And since then, of course, we spent a lot of time getting into it. We decided to start a venture firm, made a bunch of investments, but an amazing and very technical learning journey where I've gone to a lot of technical events in this space. I just came back from the Stanford Geothermal Workshop, which is probably the top sort of academic level in the U.S. For gatherings of these types. And I think that's an important job of that. When you're so specialized, you have to have an opinion and basic understanding about these things. There are I get a lot of inbound requests from other venture capitalists that are, let's say, energy funds or climate funds that might have 20 investments and maybe either nothing or one or max 2 geothermal investments. So they're interested, but they don't have the resources to go and spend 3 years of their lives to go to every
figure it out.
Right. So to your point, yes, absolutely. I think we have a responsibility to take those people in and help them learn in much faster ways than what I have learned the core bits and pieces here, so they feel better about taking those risks. And I think that's also what you get out of being a lead investor, is that you allow other investors that don't have that capacity to join on the same terms as you and essentially say, great, Torsten, why don't you just deal with the company? We're sort of getting in on the deal and providing some extra funds. So yes, in terms of how we structure the deals, and in terms of regularly having conversations with a bunch of other venture investors.
Do you think it's, because you're founding, right, Underground Ventures, it's all privately funded, right? Correct. So do you think that also that structure kind of enables you with that freedom, as what you were saying earlier, you've spent 3 years just learning everything you can about
it's quite
geothermal?
Rare. I mean, think about it in sort of your I want to say advanced career after the first couple of years out of college. Most of us get into these almost like desk jobs or now you're on this path, right? You chose your path. You're now just becoming, a manager or becoming whatever you end up being, right? And I think it's extremely rare to be given the opportunity to step out of that completely and just say, Torsten, your job now is to learn absolutely everything you can and meet everybody you can in this space, and nothing else. And I think I didn't realize at the time I said yes when Joachim asked me how much I would enjoy that journey of really having to deep dive into this space and figure out, okay, great, I don't know what that means. I need to go spend 2 weeks on that, right? It's a very rare experience to have. So it's I wouldn't say, I mean, ideally it's not necessary. I think we do need this field to also be consumable and understandable by non-geothermal experts, because we're going to need regulatory, politicians on board. We're going to need local communities on board. We're going to need traditional investors, the folks that will join the companies and work. I mean, Fervo employs 50 to 100 people. I'm not sure. Like they're getting bigger teams. A lot of folks need to get the opportunity to get into the space, and we can't require that they can spend the kind of time and effort that I have done in getting into this. So that also hopefully comes with the sort of the maturation of the industry, if you will. Mm-hmm. And Steve mentioned this thing about following the shale gas trajectory. Yeah. I definitely echo that we are in the very early phases right now of something that could be very, very big. And it's following, we're seeing Fervo, for instance, lowering their costs per well drilled by a total of 70% from well number 1 to well number, I think it was 14 or something. Yeah. They cut 70% of the cost, not because they introduced all sorts of new technology, but just because they got more and more and more experience with how to deal with that location, the geology, the equipment, the people, everything else. And I think that's just... that's very similar to how shale went in terms of learnings over time and economics. And so I feel like we're early, but on the right path.
Yeah, and then, I mean, just kind of, touching on that, I mean, future kind of insights or, like, what are things that you're looking forward to? I mean... Right. Is there
totally
anything?
Didn't answer the question.
Oh, no.
I realized that. If we go back to this, let's say hundreds of thousands of wells, if not 1 million wells, we're going to need hotter temperatures and geographically be able to do it pretty much anywhere with little regard to what particular geology we have. And we're going to need to do that at economics that work. And I'm still seeing a number of things that need to get better for that to happen. First of all, the temperature. What Steve and John and the team are doing with HEPHAE is a very big step in the direction of handling hotter temperatures for geothermal. But we're also going to need, let's say, better well completion, casing and completion technologies. The hotter temperatures and higher pressure that you get, the more strain there is on the materials, on the steel casing, the connections, the cementing behind them. And the more expensive it is, because you have typically deeper wells, you have more casing in these. You have the bigger rig you have to get, the more scarce that rig is. I mean, everything here is connected, and so we're going to need better technologies and strategies for casing and completion, for sure. I believe we're going to need better power conversion as well, because we're still using, there are a couple of, let's not get into all the strategies, but you can do a direct steam turbine, you can do an organic Rankine cycle, which is kind of the standard, the gold standard today for these systems. You can do different other strategies, other loops, but fundamentally they don't have a very high conversion efficiency. So you might produce, let's say, 10 megawatt heat, but only perhaps 2 megawatts of electricity. And so until we can step up our efficiency of those systems, we're still going to struggle with the economics. And how do you do that? Well, the problem is that is connected to every other choice you make. What is the temperature of the reservoir? What is the flow rate? What's if it's not water, what is the fluid you're using? Is it open loop? Is it closed loop? What is the percentage of steam that reaches the surface? I mean, this has everything in order to get that problem solved. It's not just about designing a better turbine. And so I'm going to stop for a moment. But these are some really interesting areas that are not easily solved.
Yeah, no. And I mean, Steve, you got some stuff coming up in the pipe, right? Like you have What is it? That little.
Well, yeah. So we will be drilling in July. We'll be ready to drill in July, which
Yeah.
is the team has done an incredible job. We were talking about earlier. I think we really had only a PowerPoint. I think probably 12 months ago, right? So obviously we've done some testing on electronics and things like that, but. We've done this before. This is not our first rodeo in terms of getting tools in the ground, and so team's done a great job. We've got a great team that has experience doing drilling tools in the past, and so yeah, we'll be drilling in July, hopefully as part of the Oxy DOE Glade project, which is going to be in the DJ Basin in Colorado. There's magmatic upwelling there, super hot temperatures. Within, we're probably going to drill at 20. They're going to probably drill at 20,000 feet. We think we're going to get to temperatures in the 300 Celsius kind of range. And the goal there is to drill like a bat out of hell through granite as fast as we can, and just demonstrate that we can do it fast. And the Oxy team is a great team, and so I love the consortium that they put together. We're working with a company called Turbo Drill Industries, who's doing the directional drilling out there. So we're partnering with them to get our tools in the ground and demonstrate that this is doable. And so we're really excited about that.
Yeah, and then just kind of explain to me, I mean, for listeners and stuff like that may not kind of understand the drilling or the geothermal side of things. I mean, your technology is applicable and could be extended upon any type of drill bit or rig or system of that nature too, right?
Well, the secret to drilling, whether it's unconventional geothermal wells or unconventional oil and gas wells, you got to put the well in the right place within a couple of feet. Ideally, that's what everybody wants to see. And you don't do that unless you measure inclination and direction. So essentially, you plot your course as you drill. You have depth, and so you just like plotting a course with a compass. So you're taking a compass reading every 90 feet, plot your course as you go, and you need every directional well has an MWD system in it. Has to have it. And the challenge is the existing systems by and large only operate to 175 Celsius. There's a few systems out there that go to 200 Celsius, but they're legacy systems, not really built anymore. So we'll be the first ones to have a system above 200 degrees Celsius. So I'm not sure if I answered your question, but
Yeah, no, you got it. And then I mean like this test in July over in Colorado, that'll be your first, and then based off of kind of that success, I mean, you're planning on kind of what would be your plans after that?
we're going to take over the world
For sure.
Any well that's drilled at temperature, we anticipate having our equipment in the ground. So that's the goal. Is to have 100% market share in any well drilled above 200 degrees C circulating temperature. We're the only system out there that can handle anything above 200 Celsius circulating temperature.
Yeah, that's pretty incredible. And I mean, yeah, you're gonna just take over the world, have a million freaking wells, all with HEPHAE.
Yeah, that's basically it. I mean, we're ahead of everybody, I think, and there's reasons for that. It's not that other people can't do this,
Yeah.
but because of Torsten and Exascale, they've drank the same Kool-Aid that we've drank. Some of it we mixed ourselves and drank it, but I like to refer to it as mixing up Kool-Aid and getting people to drink it, and not only John and I had to mix our own Kool-Aid. We drank it, and then we had to get the team to drink it. And it's a huge leap of faith to say that you're going to drill, that you're going to work on electronics that are going to go to 300 degrees Celsius, which is what we're doing. When there isn't a single well in the world that's being drilled directionally above 200 degrees Celsius. You've got to believe that this is going to go, and we believe it's going to go. So
Yeah.
And that's what we believe it's going to. We believe it's going to super hot rock, where we think the 210 degrees Celsius system that we're developing now will give us some running room, because it's going to take a while for casing and cement to kind of catch up. But we think this is going to progressively go deeper. It's progressively go hotter, and you're going to progressively need higher and higher temperature electronics and other things. But we're good right now. We went through. We've got there's a state-of-the-art testing center here in Houston, Dynaqual Labs, on the north side of town. We're right in the middle of. We're right at the end of finishing our testing, and the system is withstanding environmental testing that no MWD system has ever survived. So the lab, they've never seen anything like our system. So as days go by, we get more and more confident that we've got this thing figured out. And then the other thing I think is that we need to mention is that we're hopefully going to be leveraging off of some of the aerospace stuff that JPL is doing, part of NASA. So they're trying to put a rover on Venus, 500 degrees Celsius for 30 days. So they've got a lot of the stuff that we need, and we've already started that conversation there. So hopefully that's going to help us. We got some help to get to 500. So that's what we're looking at.
Yeah, that's awesome. I did not know about the Venus bit. That's cool.
Yeah. We actually we went out there and we got it's pretty cool what they're trying to do on Venus.
Mm-hmm.
And there's a couple other rovers that they got out there that they're pretty cool too. But we won't talk about that now.
I got you.
If I could just add to that piece about belief that you mentioned, that you got to believe that this is happening and convince everybody around you. I have definitely, by now am convinced, and I've drunk the Kool-Aid. Absolutely guilty as charged. But I do feel like there are some other bits and pieces here we can hang our hats on. First of all, what other people in the industry are saying, and the inbound demand that you are getting, for instance, for these tools are quite a bit more tangible than a belief. It at least helps reinforce that belief. But I think another thing that we as a specialized venture capital firm are thinking a lot about is that it's a little bit of like a chicken and the egg problem. That if you don't have those solutions, as Steve said, you don't have your MWD tool, you don't have your casing, you don't have your bits and pieces of building a high temperature system, and surface equipment, then it's a very hard decision to make. But if you have a little bit of let's say a universal tech stack that you can pull bits and pieces from, you say, okay, great, well, I have HEPHAE, so I can do this. I have these guys, so I can do this. We see it a lot as our job to go and invest and help those companies become that tech stack, so that it's still, you're not locked into any of them, but you have those choices, so that when you have to assess, am I going to do a well at, let's say, 175C or one at 250C, you now have those choices. So in that sense, we're not just taking a bet that it's going to happen. We're actually, through these investments, hopefully making some of that happen, or at least making that choice available to a wider amount of people. I think there's belief and there's action to make it happen, as in money investments.
Yeah.
And then there is reading the market, as in inbound requests.
Yeah. And I mean, like, speaking on that belief and kind of education and kind of bit, so y'all are both, like today it's March 12th, and then I believe, what day is it? Wednesday? Yeah, so
Wednesday.
Tomorrow, Thursday, sorry, it's all blurred for me. So Thursday there's going to be a Groundbreakers tied in with Groundbreakers Launchpad, and it's all kind of tied into the big old CERAWeek bit. It's not necessarily a CERAWeek sponsored event, but it's a satellite. So you're going to be a judge.
Yep.
Steve, you're going to be
the whole thing's rigged. The whole thing's rigged, guys.
Yeah.
You weren't supposed to say that.
No, but the geothermal venture and startup community is still pretty small.
Yeah.
So I'm not shocked that even though I volunteered to be a judge without knowing who'd be there, I find out that Steve is going to be pitching. That is pretty much how we all know each other in this space. But I'm looking forward to it. I think it'll be really good. It looks like it'll be a well-attended event. So
it's the kind of thing that needs to happen at this point in this industry. We need to over-communicate and share learnings, and you got to give Ever and Fervo a lot of credit, because they share, especially in the case of Fervo, sharing a lot of data, a lot of results, and but good, bad, and medium, and so it's so you have to do that. I think. Yeah, I mean, you have to obviously be careful about what you say about IP and proprietary stuff, but at the end of the day, if we're going to make this happen, we all need to work together, and we need to leverage off of the experience of the oil and gas community, and and the geothermal people. We need to just all work together to make this happen as fast as it needs to happen. It needs to happen freaking fast.
Yeah, yeah, and I mean, we talked about this before, like off camera, but like the hydrocarbons at the clean energy and kind of this renewable, secure, base load, abundant, however many adjectives you want to throw into there, geothermal energy source.
Yep.
I mean, just kind of like, takeaways from this conversation right now, what would you say is kind of the things that you look at and see in terms of leveraging that hydrocarbon energy, oil and gas, technical expertise for the geothermal industry?
Oh, I mean, as Steve said earlier,
Yeah.
we would not have next generation geothermal without the shale gas development, adventure that has been. So even though there are other ways to develop a reservoir, you can frack, you can also drill, you can do a lot of other things. There is no doubt that we owe right now everything to the oil and gas industry. Let's be honest. But I don't think we will in the future, and I think that's really interesting. There is an opportunity for them also to transition into using a lot of the same tools, a lot of the same people, assets, rigs, know-how, partnerships, all of that good stuff can be put to use in a very different type of energy that in many ways has the future ahead of it. And I think that's what's so cool about this, is that we're not out here building a completely new set of skills or requiring all this infrastructure that doesn't exist. Like, we're really very much able to build and scale this with all of the existing assets.
Mm-hmm.
I mean, you come from that world, Steve. You have an enormous amount of experience in that space. Wouldn't you agree?
For sure. And the other thing I would add, Torsten, is that I can't tell you in my 44-year career how many times I've been faced with something that people have told me is impossible. 5 years later, you got to have it on every freaking well, right? That's how fast it changes, and that's what's happening here with geothermal. And look, this is the way it's going. I'm 100% convinced that. Obviously, otherwise I wouldn't be doing it. But so the train is leaving the station. Time to get on board, because this is the way. This is where we're going. The geothermal train is leaving the station. You can get on board now. It's coming.
Yeah, no, and I mean, I couldn't thank y'all enough for being here, letting us kind of share, some of the insights and just being able to propel this kind of industrial innovation conversation. And I'm just kind of curious, what is kind of the lasting kind of forward-thinking thoughts or things that you're looking for toward the future? To your point, just while this train is leaving the station, Steve, anything up on the horizon for y'all?
In terms of
you individually, maybe you got a band, another show going on. You got anything lined up this weekend? What's going on?
No. That's a different story. No, really. Unfortunately, my music career is taking a back seat. I managed to jump in here and there and perform every now and then, but my music career is kind of on the back burner. But that's okay. Yeah. Appreciate that. But I tell people I just wish I was 20 years younger so I could be part of this thing as this thing unfolds a little longer than I'm going to be, because I think this is just amazing what we've tapped into here.
Yeah. No.
So I'll say two things.
Yeah.
One, Steve is really good. You got to check him out. The Steve Craze Band, amazing.
Thank you, Torsten.
Two, I think in this sort of the big unlock that I see in this space is as sort of a path towards modularity. Think about how wind turbines and solar have grown so much because you can just manufacture, thousands and thousands of these things and ship them around the world. Now, geothermal is dependent on very much the geology you have and local permits and all that stuff. But that move towards standardization, modularization, and scale of how we roll this out, that to me is the big unlock. And that is what we're seeing in little bits and pieces of different parts of the system. There are hints of modularity that I think will be very, very interesting to follow.
Yeah, it's almost similar to the. I was just watching that deal about modular nuclear, right?
Small modular reactors. Yeah.
It's kind of similar, isn't it?
That still has a long way to go.
Yeah.
But the reason why that is a huge opportunity is exactly that.
Yeah.
That is that we can mass manufacture them.
Yeah.
So I'm very excited about following that particular trend.
Yeah. No, I mean, on that note, I mean, again, thank y'all so much for letting us have this conversation.
Thanks for having us.
Thank you.
Yeah.
Thanks for spreading, helping us spread the word.
Oh, for sure, for sure. Thank y'all so much. And until next time, thank you.